Augmented Reality Mobile Robotics, or ARMOR, is a professional design and simulation tool on iOS and macOS for the robot operating system, ROS, and MuJoCo. Today we'll be talking about the user interface, UI design, and standard workflow. The ARMOR UI is designed around three main navigation panels. The sidebar on iPad or Mac, or first screen on iPhone, is where you can load robot projects, create new ones, or import from Universal Robot Description Format URDF files, which is the industry standard XML format used in ROS and simulation solvers like Gazebo and Drake. Clicking on one of the robot models will direct you to the detailed view. Here is where you will view your robot in 3D, in spatial reality, or the plain text of the XML description files. Clicking on the notebook icon will direct you to the editor, where you can edit project level settings or directly edit fields in your XML file. The sidebar panel is where you can select and navigate between your different robot projects. ARMOR comes pre-packaged with a few example models, so you can get a feel for what you can build using URDF and MuJoCo. Once you've created or imported a few of your own robots, you will be able to load them in the section directly underneath the examples. When you tap one of the models, you will see its count of links and joints and a description if one was given. Underneath the user-generated robots section, you will find information about ARMOR's premium features, whether you are currently subscribed, and a button to open the upgrade dialog. Pinned to the bottom are buttons to create a new model or import an existing model from URDF. Once you have chosen a project, you will be directed to the Robot Detail view, where you will spend most of your time in the ARMOR app. The view is tabbed, with sections for 3D, spatial, and XML. The standard, or virtual view, is similar to common CAD and simulation software, and renders your robot in a 3D viewport, which you can manipulate using one or two finger gestures. There are optional axes, grid, and other features. The Spatial tab will present your same 3D robot model in AR, overlaid on top of real-world surfaces that are detected by your device's camera and the LiDAR sensor on iPhone and iPad Pro. On the XML tab, you can see the full text of your URDF and SRDF files. These are presented using IDE-like syntax highlighting and selectable theme. Each view includes a column of buttons on the lower left that modify how the model is visualized, and buttons on the lower right that allow quick editing of common model attributes. The Project Editor tab is accessed from the notebook icon in the top toolbar. At the top, there is a settings section where you can modify solver properties such as gravity or simulation time step. Below this is the Robot Editor, which provides complete control over advanced features in your URDF and MuJoCo workflow. Here you can expand to view and edit properties of each of the links and joints in the URDF file. This is designed for experienced robotics engineers who are seeking fast iteration over XML properties. Underneath is the Semantics section, where you can specify joint groups and their state values, as well as other properties in the SRDF file. Coming soon to the editor are robot sensors and transmissions. Now that you have seen how the ARMOR user interface is laid out, you can begin learning the fundamentals of robotics engineering with URDF. I recommend searching the internet for open source models of real-world robots. Our Finding URDF Files page is a good place to start, where we have listed industry vendors and GitHub repositories. You should also read about how joints and links are defined in the URDF file, as these are fundamental mathematical and programming concepts for all robotics engineering projects. With this knowledge, you will be well prepared to start importing and designing your own robots with ARMOR.